Good morning. So welcome to my next lecture series. It is regarding the block diagram reduction. In our previous lecture series, we have seen the introduction towards the block diagram. What is a block diagram? It is the pictorial representation of a system. So for a complex system, the block diagram will be very complex, and deriving the transfer function for that system is a complicated issue. So in order to overcome this, now we have the block diagram reduction, and in our previous lecture series we have seen some 7 standard rules which are applied to reduce the block diagram and find the transfer function. So today we are going to solve a problem how to reduce a block diagram and arrive the transfer function. So it is a block diagram of a system. So now our main objective here is to reduce this block diagram and find the final transfer function. So we all know what is the transfer function is. So now we have the input R of s and we have the output C of s. So our transfer function is the Laplace transform of input to the Laplace transform of output under standard conditions. So we are going to obtain that using block diagram reduction. So now as per our rule, now here looking into the block diagram reduction, mostly what we will do is we will proceed from the output to the input. We will start reducing from the output and we will proceed towards the input. So in that case, now here we have the branch point. We have the branch point after the block G4. Now our first step here is to move the branch point before this block. The branch point is moved before this block. So by moving the branch point according to our the rules of the block diagram reduction. So while moving this, so what I will do is I will just erase this. I will update in this diagram. So what I am doing now is I will just move the branch point before the block. So I have H1 and then we have another feedback. So while moving the branch point before a block, now what I have to do is whichever block I am moving, I have to include that block over here, that is G4, and here again I will include my block G4. So this is the rule, moving a branch point before the block. So I have included the two blocks in their path, feedback path. So now this is my first rule, that is moving branch point, so that is before the block. Now my second step over here, now what I am going to do is I am going to cascade two blocks, that is blocks which are connected in series. I am going to cascade to these blocks, and then we have a loop over here. I am going to eliminate the loop. So my second step is cascading blocks and eliminating feedback. So this is my next step. So cascading blocks, I'll just simply add or multiply these two blocks. So I'll just multiply these two blocks. I'm going to write the transfer function as, so it is G4 H1. So I have cascaded the block. Then I'm going to reduce this block into a single block. So that is elimination of feedback path. So our elimination of feedback path, it is given by C of s by R of s is equal to G of s divided by 1 plus G of s into H of s. So accordingly we are going to reduce this block. So here this is my G of s and this is my H of s. So I am going to reduce it. So while substituting this, you know, we will get it is G3 divided by 1 plus G3 into H3. So it is G of s, which is G3, and H of s is G4 into H1. So this entire thing I will reduce. I'll eliminate the block, and now I'll put it as a single block where my transfer function is G3 divided by 1 plus G3 G4 into H1. So our step number 2 is completed, where we have cascaded two blocks and we have eliminated the feedback path. So now my step 3, it is, again you can see these two blocks are in cascade. So cascading of two blocks. cascading blocks in series. So cascading blocks. So what I'll do is I'll just simply multiply. So G2 over here. Now I'll eliminate this block. So I have cascaded the blocks. Okay, I have cascaded the blocks. I have eliminated. So my step 4. Now you can see now we have another feedback path over here. So I am going to eliminate this feedback path again using the formula C of S by R of S. Now which is equal to, so it is G of S, which is, this is our G of S and this one is our H of S. So it is G2 G3 divided by 1 plus G3 G4 H1, the whole thing divided by, it is G of S divided by 1 plus G of S. So I am writing it again, G2 G3 divided by 1 plus G3 G4 H1 into our H of S, which is nothing but H2. So finally my transfer function is, it is G2 G3 divided by, it is 1 plus G3 G4 H1 plus it is G2 G3 H2. So this is my, these two denominator, after taking LCM, these two get cancelled. This is my final transfer function, that is after eliminating this feedback path. So I have eliminated this feedback path. Now I am getting the transfer function as, it is G2 G3 divided by 1 plus G3 G4 H1 plus G2 G3 into H2. So this is my next step, that is step number 4. I have cascaded the blocks. So step 5, cascaded is eliminating feedback, that is my step 4. Eliminating my feedback, that is my step 4. And my step 5 now, it is cascading again blocks, cascading the blocks. So which is nothing but this G1 I will multiply over here. This is my cascading of blocks. So this is my next step. And finally, now you can see, now this is another feedback path. So eliminating this feedback path again. So we have to eliminate this feedback path. That is my step 6, elimination of feedback path. So what I do is, now here in this case, this is my G of S and this is my, this is, I think it is G4, yeah. So it is my H of S. So I am eliminating this. So what happens is, so it is G of S, which is nothing but my C of S by R of S is equal to, it is G of S. So G1, G2, G3 divided by 1 plus G3, G4, H1 plus G2, G3, H2. This is my G of S, whole thing divided by 1 plus again G of S. So G1, G2, G3 divided by 1 plus G3, G4, H1 plus G2, G3, H2 into, now my H of S is nothing but G4. I am going to eliminate the feedback. So now this is my G of S divided by 1 plus G of S into H of S. Now I am just removing the numerator, that is after taking LCM. Now my transfer function becomes G1, G2, G3 divided by, so I am just taking my LCM, so it is 1 plus G3, G4, H1 plus G2, G3, H2, okay, and then the remaining it is plus G1, G2, G3. So this is my C of S by R of S. So after eliminating this feedback, now my transfer function, now it becomes, so it is G1, G2, G3 divided by 1 plus G3, G4, H1 plus G2, G3, H2 plus G1, G2, G3. So we are into the last step of solving this problem, where you can see it is just cascading of these blocks. So my step number 7 is cascading of blocks. So cascading of blocks. So I'll just remove this, I'll just put over here. Now this is my final transfer function. So when I just write my final transfer function, now it is C of S by R of S is equal to G1, G2, G3, G4 divided by 1 plus G3, G4, H1 plus G2, G3, H2 plus G1, G2, G3. So this is my final transfer function arrived after reducing the complex block diagram using block diagram reduction technique. So here the applying of the rules, we don't have any standard procedure. Now it is up to the problem solver to see which rules to apply first and then to reduce the complexity of the problem. So thank you for watching. Thank you very much.